Hello everyone, today I'll show you how to do the size proportion trick for TF2. The size proportion trick is very useful as it permits you to conserve the proportions of your custom model and scale all the TF2 animations accordingly. Here is an example of a model that uses the size proportion trick. I'll be using this Mimi Sentry model for the tutorial. You can see the difference without using the size proportion trick and while using it. Before starting, I want to give a shout out to Reddy on Game Banana for having helped me figure out many parts of how the size proportion trick works. Without them, I wouldn't have known how it works, so if you're interested in TF2 models, you can check their Game Banana page. They make cool stuff. Also thanks to loyalists for permitting me to use their size proportion trick files for this tutorial. First, open Blender and import your custom model and the TF2 model you want to port to. You have to pose your custom model using the custom model skeleton to have the same pose as the TF2 model, but only by rotating the bones of your custom model, not by moving them. It is crucial that you try to make the pose as close as the TF2's model pose as possible. You can scale your model and move it to make it easier to make the same pose. After you're done posing your model, scale your model to whatever size you want it to be in-game. You can make your model shorter than the TF2 class, larger, wider, slimmer, or the same size. For example, here's a mod I made that uses a scaled down model. Now you want to apply the armature modifier on your custom model. This is when the important part starts. Hide the TF2 model and select the TF2 model skeleton, switch to pose mode, and move each bone of the TF2 model skeleton to the positions of the bones of your custom model skeleton. For example, move the bip pelvis bone of the TF2 skeleton to where your custom model skeleton's pelvis bone is located. Always move the bones starting from the bip pelvis bone, then the spine bones, and then the limb bones. If your custom model only has 2 spine bones, move the appropriate TF2 spine bones to match them, then place the missing spine bones halfway between them. If your armature displays its bones in form of octahedrals like you see here, and you're not sure of where to place the TF2 bones, then the correct way of doing it is by placing the TF2 bones at the start of the octahedral bone, also known as its base. Once you've moved all the TF2 bones to their new positions, in pose mode, apply pose as rest pose. Then switch to object mode and select your custom model and the TF2 skeleton, then press Ctrl P and select armature deform. Make sure to rename the vertex groups of your custom model to fit the TF2 model's vertex group names. You can hide the custom model skeleton to avoid errors. Then, in object mode, select the TF2 skeleton, switch to pose mode, press A to select all the bones. On the bottom part, switch to the dope sheet and then the action editor. Move the cursor to frame 0. Press the I key to insert a single keyframe for all of the bones. Then rename the animation to Deltapose. Make sure your Deltapose animation only has one keyframe and that it's the same as the pose of the TF2 skeleton. The TF2 skeleton should have the same pose in rest pose, pose mode, and in the Deltapose animation. Once that's done, you can export your custom model to where you decompiled the TF2 model. And export your Deltapose animation as well. It will be in a folder called anims within your decompiled folder. Now we'll work with the QC file. Open your QC file. Make sure to have the QC file set up for player models by removing the face flex section, setting up the CD materials and skin families, etc. Remove all the defined bone lines. Basically, when the QC file doesn't find any defined bone lines, it will automatically use the defined bones of the given model without having to generate them. Although generating the defined bone lines and then putting them in the QC file can sometimes give different results, so keep that in mind. But for now we will remove them as it's what worked for me in the vast majority of cases. Remove the waitlist. Remove the IK section. The size proportion trick does not support hand inverse kinematics, which is why I noted earlier that you should make your custom model's pose as close as the TF2 model's one. This way the hand positions will be around the same place and you can fake the IK look. Remove the IK rule lines from the ragdoll and ref animations. Before the sequence section, add this script. This is the script that will apply our Deltapose on the TF2 animations and will scale them appropriately to fit our model. Something important to note is that TF2 player models don't use just the class.mdl file for animations, but they use other files that contain animations as well, usually 2 more files that are linked to the player model file. Those usually being class_animations.mdl, which contains most anims, and class_workshop_animations.mdl, which contains workshop taunt animations. These files are linked to the player model file in the QC file using the include model QC command. Find the include model commands in the bottom of the QC file. We can ignore the user animation one. Here we can see both the class animation file and the workshop one. To make things easier, modify the path of the workshop animation file to be just player/class_workshop_animations.mdl. You can now compile your model and see the scaled animations for yourself. In case the result is vastly off from what you would expect, you can either rework the Deltapose to be more accurate or you can mess around with the defined bone lines. Maybe try using the TF2 defined bone lines or generating the defined bone lines for your custom model, then putting it back in the QC file. In case your model is facing downwards, you can rotate the delta pose 90 degrees on the x-axis and then select all the bones, press I, and re-export the delta pose and then recompile the model. Once you reach a satisfactory result, you can try launching TF2 and testing your model in-game. Use the third person and third person Maya mode commands to view your model fully, and cam ideal this to configure the camera distance. You will notice that your model in-game will look correct, but the loadout model will look completely distorted. This is normal, as for some reason, the loadout model uses the class_animations.mdl file, and we have not applied the size proportion trick to that file yet. To fix this, we need to remove the size proportion trick from our player model and put the size proportion trick in the class_animations.mdl file and the class_workshop_animations.mdl file. You need to make sure that the size proportion trick is only present in the class_animations.mdl file and the workshop one. If the size proportion trick is present in both the player model file and the animation file, it will apply the scaling 2 times and it will break your model. Now you want to go to this Game Banana page that I will link in the description for the Toho Fortress mod by Loyalists. You will find a zip archive named anim. This archive contains the class_animation MDL files for each class already set up for the size proportion trick. Once you download it, extract the archive and open the folder. Then open the folder of the class you're porting to. First, open the animations.qc file. Change the model path to just player/class_animations.mdl. Now you want to decompile your player model that has the size proportion trick into another folder. Doing so will give us 2 essential files, a_proportions.smd and reference.smd. Rename the a_proportions.smd file to proportions.smd. Copy the reference.smd file on your custom models.smd file and paste it in the animation class folder that we just opened. Open the .qc file again. On the bottom there's a bunch of things we need to change. For the reference animation, change the path to just reference.smd, which means it will look for the file in the current directory where the QC file is located. And on the other ones that have proportions in the name, you want to edit the file path to point to your custom model, again located in the same directory as the QC file we're working with. The engineer animation files are the only files from the 9 classes to be split into 2 separate animation files, which means that you'll have to link the second animation file to the player model QC using the include model command. Here we will change the paths of the sequences in the second QC file the same way we did with the first QC file. Then do the same thing for the workshop QC file. Once you do that, go back to the folder where you decompiled your custom model. Copy the proportions.smd file and the reference.smd file. Open the class_animation folder and paste the files there. Do the same for the workshop_animation folder. Now compile the animation QC file and the workshop animation QC file. In HLMV++, you should notice that your model looks distorted. This is because we haven't yet removed the size proportion trick from our player model QC file. Go to your player model QC file. Remove the size proportion trick script from there. If you're making an engineer mod, make sure to include the second animation file. Then recompile your model. Now your model should look correct, and if you open TF2 you should notice that both the in-game model and the loadout model are now correct. If the ragdoll animation doesn't play, replace the ragdoll.smd animation in the player model decompiled folder with the Deltapose.smd animation. Then recompile your model.